So this is a brief tutorial on the energy flow that occurs within an ecosystem. So we're going to talk a little bit about food chains, food webs, and food pyramids, and how each of those three things are going to help us to understand better how energy moves or flows through an ecosystem. Remember that an ecosystem is going to be all of the living and non-living things that are going to exist in a given area. The living things are known as biotic factors or living factors, and the non-living things are going to be considered the abiotic factors in an ecosystem. And both those two different factors, biotic and abiotic factors, can play a role in limiting the number of species that can live in a given area. And all of those things work together to kind of interact, to play out ecology, which is the study of those interactions that exist within an ecosystem. So let's first take a look at what we see when we look at a food chain. So this is an example of a food chain. And as we look at a food chain, we're going to see that it's a linear flow that exists as we move from one side of our chain to the other. So if we're going to look at this particular food chain, we're probably going to want to start looking at the producer first. So here is our producer over here. A producer is going to be any organism that is going to make its own food through the process of photosynthesis or something to that effect. So it's going to use the sun to make its own food. Next in line, we have our primary consumer. Our primary consumer is going to be the first of consumers to actually eat a producer. And if we think about a primary consumer, the word consumer is going to be any organism that is going to have to eat or consume its food in order to survive. So it can't make its own food, it's going to need to eat. So in this particular case, the grasshopper is going to eat our producer, in this case the grass. Now we can move on to our secondary consumer, and when we look at our secondary consumer, the bird in this case, the reason why it's a secondary consumer is because it is the first consumer to eat a primary consumer, making it secondary. We move down the line, we have a tertiary consumer last in our fox. Now I want to pay particular attention to the arrows that you see in this image. Each of these arrows is facing in one direction. So the flow of energy in this particular food chain is going to be in one direction. So we can see energy movement in one direction. So there's energy inside of our plants, and that energy is going to get passed from organism to organism. So there's energy here in our producer, and that's going to get passed to our primary consumer. Then that energy is going to get passed to our bird, which will then get passed to our fox. So that is going to be kind of the chain that we're going to see as we move from one side to the other of this food chain. Now, a couple interesting things to keep in mind here. First of which is the movement of energy. So the biggest thing you need to kind of walk away with this from is understanding that energy is going to flow, and the arrow points in the direction that the energy is going to flow. So, hey, grasshopper eats producer, so the energy is going to go into the grasshopper. We face that arrow towards the grasshopper. That bird is going to eat that grasshopper, so the arrow is facing the bird. The number one reason why people get questions wrong on a test or a quiz based on food chains is because they put the arrows in the wrong direction. Now, this food chain will not last forever. We typically don't have more than a tertiary or quaternary consumer, because eventually you will see that there's not enough energy left to support this particular food chain. Two other walkaway points here. One, you'll notice that the sun is not in this image. However, the sun does exist. It is going to be the source of all energy for living things here on Earth. Specifically, it's going to provide that initial energy for the producer, which will then be passed to the primary consumer and so on down the line. And then the second walkaway point here is that you also notice that we do not have any decomposers. in this image. Typically they're kind of left out or put in only food webs, but eventually all things die, and when things do die, they will be passing their energy onto the decomposer, which will restart this whole process. Next, let's talk about food webs. So this image right here is a food web. You will notice that it is much more complex than our food chain we saw on the previous page. And this, a food web, is much more the reality of what you're going to see in an ecosystem. Food chains are just kind of one selection or one part of the food web, but the reality is that no organism is just going to eat one particular species. That typically would cause that organism or that species to die out, which means they probably wouldn't last very long, and if they've made it this far through evolution, they're probably going to have a variety of food that they're going to eat. Now, a food web, by definition, is really just a bunch of different food chains put together. So, for example, our carrot down here at the bottom, if the carrot is eaten by the deer, and then the deer is eaten by the fox, that's a food chain. Our carrot is our producer, our deer is our primary consumer, and our fox is our secondary consumer. So it's a fairly small food chain inside of this food web. Now we could also talk carrot to rabbit, rabbit to owl. So we see some complexity there again with different options and different availabilities. Now, a couple walkaway points from the design of a food web. First off, you will notice that down here at the bottom is going to be our producers. And then as we move up, we're going to get into our different types of consumers. So our next level kind of here are our primary or our first consumers. And then our next level, we have kind of our staging for our omnivores or our secondary consumers, kind of in this area right here is going to be our second. And then at the top, we're going to see our tertiary consumers or maybe even quaternary consumers. And those tend to be our carnivores. So we've got our herbivores down here. We've got a lot of omnivores that could go either way, whether they're a primary consumer or a secondary consumer. And then we've got our tertiary, which are typically going to be our carnivores that are at the top of this particular thing. So as we kind of look at all of this different information, as we go from producers to consumers, there's an order to the particular food web. We typically put the producers at the bottom, primary consumers next, secondary consumers next, tertiary consumers next. You will also notice that, again, the arrows are moving in the flow of energy, so a lot of energy at the bottom, a little energy at the top. Now let's talk a little bit about the interactions that exist within this particular food web. And there's a lot of things that could happen. So say, for example, that a disease came along and killed out all of the carrots. We could talk now about some of the interactions that we would see happening here. Well, first thing we would notice is that our deer population, which eats the carrots, doesn't have a food source anymore. So we would suspect that the deer population would decrease. And if the deer population is going to decrease, that means poor little fox is only going to have two options for food now, which would be our bird and our rabbit. So two instead of three. It's going to have to do one of two things. The fox is going to have to be really good at getting rabbit and bird where it wasn't before, or more likely what we would see, at least in the immediate time after the loss of the carrot, is that the fox population would decrease as well. Now, we could keep going, and just to kind of show you the different levels of interactions here, well, if the fox population is going to decrease, that means the rabbit population might increase, because instead of having two predators, one the owl, two the fox, it now only has one. So maybe we'll see that rabbit population increase. But then again, it did lose the carrot, so maybe that might decrease. So you can kind of see the complexity, and a lot of times when we talk about the interactions in a food web, you have to give the details of the explanation. You can't just simply say, oh, you know what, the carrot's going to decrease and be done. You have to explain why. Well, you know, the deer is going to decrease because its food, availability of food, is going to decrease. Now, one of the other interesting things that we will spend some time talking about in here is the word competition. So, for example, if we were to remove our grasshopper from this particular food web, we would see that now the squirrel, which eats the grass, is going to have less competition for that grass. So if it's got less competition for that grass, we would suspect that the squirrel population would increase. So if you've got 3 organisms competing for one food source and one of those organisms goes away, less competition. However, if you've got, it's kind of a vice versa here, if you've got 2 organisms fighting over 2 different foods of some kind, and one of those foods go away, now you got increased competition. Smaller amount of food, still the same number of organisms at the top. So there's a lot that you can do to talk about the interactions that exist inside of a food web, and being able to identify those increases and decreases is extremely important in being able to analyze a food web. All right, the last type of thing I want to talk about related to energy flow in an ecosystem is energy pyramids. An energy pyramid is basically just taking a food chain, and instead of doing it linear or horizontal like this, it's actually just going to stack the particular organisms up and down, kind of vertical. So let's take a look at this. So we've got at the bottom our first trophic level, which is our producer. So this might be our grasses if we go back to our original food chain that we looked at. And then we might have our next, which is going to be our second trophic level. Now each trophic level is just the next level up on the pyramid, which is going to be our primary consumer. So that could be our grasshopper. And then next we have our secondary consumer, which in this particular case could be our bird. And then finally we have our fourth level, which is going to be our fox, which is going to be our quaternary, or excuse me, our tertiary level to this particular energy pyramid. So if we look at this and we look at all the different levels here, we're going to notice that energy flow, and this is kind of how we evaluate the energy flow inside of a particular ecosystem. We look at kind of the different components and we look at what happens over the course of time from the bottom to the top. So if there was 1,000 units of energy down here at the bottom, we only get 100 units of energy here, because remember, energy is going to be transferred. So we can kind of have like our little arrows here. As we move up, each level is going to have a new set of energy. Now, here's the problem. Energy flow in an ecosystem is not very efficient. And what we end up with is what's called the 10% rule. And what that means is that each organism only gives 10% of the energy it had to the organism that eats it. So if there was 1,000 units of energy available down here at the producer level, and it was eaten by that grasshopper, the grasshopper would only get 10% of that, and 10% of 1,000 is 100. But then when the grasshopper gets eaten by the next level, the secondary consumer, which would be our bird, it only gets 10% of that, and 10% of 100 is 10. And then when we get to the fourth level, we only get 1 unit of energy, 10%. So you can see that as we go up our energy pyramid, we're losing energy. So there's not a lot of energy available at the top, which means that you're going to have not a lot of organisms actually be able to be sustained at the top. So only 10% of the energy is going to go from one level or one trophic level to the next. And even though we don't have it on here, we do assume that the original source of all energy for, again, this food pyramid, just like we did with our food chain, is the sun. So the sun's going to provide initial energy, and then from there, we're only ever going to get 10%, 10%, 10%, 10%. So less energy is available to each organism as you move up the food or energy pyramid. So in order to compensate for that decrease in energy or the less energy available, we see that the consumers at the top have to eat more. So a tertiary consumer has to eat 10 times as more as a secondary consumer, or 100 times more as a primary consumer. So at some point, there's just not enough energy left in the ecosystem to actually support this particular chain, which is why food chains only have 4 or 5 organisms in it. We're not going to see a ton of organisms. So this is just a great overview of some of the different components of energy flow within an ecosystem. Next, we're going to talk about how we can limit the number of organisms in a ecosystem.